Today I'll solve heat equation by using Crank-Nicolson method. Here is the heat equation. Dou u by dou t is equal to dou square u by dou x square. So here alpha is equal to 1. Now boundary and initial condition that are given. Initial condition u x comma 0 is equal to 0 for 0 less than equal to x less than equal to 1. So actually domain is 0 to 1. Boundary condition u 0 comma t is equal to 0 for t greater than 0, left boundary fixed at 0. U 1 comma t that is equal to t for t greater than 0, right boundary initially increasing with time. Now here is the objective. Solve using Crank-Nicolson with Gauss-Seidel method for two time step with lambda is equal to 1. We can solve by using TDMA, but here we will solve and we will use Gauss-Seidel method to solve Crank-Nicolson equation. So now the earlier video already I discussed about how to get the Crank-Nicolson equation. So here is the special case of the Crank-Nicolson equation. So lambda is equal to 1. If I substitute lambda is equal to 1, so equation become like this. And then if I reorganize, so equation become this I n plus 1 is equal to 1 by 4 ui minus 1 n plus 1 plus ui plus 1 n plus 1 plus ui n minus 1 ui plus 1 n. So this is the reorganized equation. So that equation can be solved by using Gauss-Seidel method. In Gauss-Seidel, we use the most recently computed value for ui minus 1 n plus 1 and keep the old estimate for ui plus 1 n plus 1 until it's updated. So now I'll show you how to do that. So now here this is the equation. Okay, so using this equation we will solve that. Now here the discretization parameter. Let's use the following discretization. So special step del x I'm taking as a 0.25, that is 5 special nodes including boundary. So here, so this is 0, then 1 2 0 1 2 3 4 maybe 5. So this is 1. Okay, so here 1 2 3 4 5. Okay, so up to this. Up to this. So this is the 4 point. So this is 1. So interior 3 points we have to solve. So here lambda is equal to 1 and lambda is equal to, we know the del t by del x square. So as lambda is equal to 1, so del t will be lambda into del x square. So 1 into 0.25 square. So that is 0.0625. Two time step we have to calculate. So 1. So we start from t0 is equal to 0, then t1 is equal to 0.0625 and t2 0.125. So that two step means that t is equal to t2. What will be the this node value we have to calculate. Now here is the that computational grid and boundary condition. So here, so this is 0, then 0, and this is x is equal to 0 and x is equal to 1. So this is the computational grid. Okay, now that is t is equal to 0 and then t is equal to 0.0625, t is equal to 0.125. Okay, now initial condition is here. So this x 0, so all values are 0 here. So these values are 0 0 0 0 0. Okay, and that at that boundary condition at 0t, so here 0t, so these values are also 0, and this boundary also at t is equal to 0, so this is also 0. Now at t is equal to 1, t is equal to t1 is equal to 0.0625, so boundary condition 0 1, that is 0, and this value is 0.0625. Similarly, at t is equal to t2 means 0.125, again this boundary condition is 0, this boundary condition is at u1t, the t means t is 0.125, so 4 2, so that will be 0.125. So now we have to calculate this value, this value, this value, this value, this value, this value, this value. At t is equal to 0.0625, we have to calculate this value, and this value. At t is equal to 0.125, we have to calculate this value, and this value. this point, these nodes we have to calculate. Now how to do that? So we know that equation, Gauss-Seidel formula, means after putting lambda is equal to 1, so lambda is equal to 1, we got this equation. Okay, so now for this equation, if you see that if you want to calculate this point, you need this point value, this point value, this point value, this point value, summation divided by 4, so you will get this value. Okay, so based on that we'll do the calculation. Now here, so at initial condition, so if you initial condition, all these values are 0. Okay, now boundary condition. So here if you see, if I here if you see that computational node, so here, so these values are zero, these values are 0 0 0 0 0, and at t is equal to 0.065, this boundary is 0, this boundary 0.0625. so now if I want to calculate this point, that is u11, so we need this value, this one, this point, this point, this point, but we don't know what is the this point value. So initially initial guess, so we first we have equation, 3 equation for this node. We have this equation. Okay, so right now I'm not plugging all this value. For this boundary node, means 1 2, so this is this equation, and for this boundary we have this equation. So 3 equation we have, but we don't know this value, this value, and this value, so we have to use Gauss-Seidel method. Okay, so 3 equation, and we don't know that this point value, this point value, this point, 3 equation, 3 unknown. So from there we use Gauss-Seidel method and calculate all this value. So now initial guess is 0, u11, u21, u31, 0. So if I put that first iteration, first step, so u11 will be 0. Second iteration, again u11 we got that 0, we plug that updated value. Again if I calculate u12, that will be 0. Now here u3, that is u21, so and u41 is there, u41 is there, u41, so u41 boundary value we know, so that is the value first iteration. u31, others are 0, we'll get 0.015625. now similarly we have to update, and when that consecutive 2 value will be same, we will stop the iteration. Now second iteration, so iteration u11 we got that is 0. Okay, so using this equation, okay, so again that is 0. Now u21, so here if you say here, if you see here u21 required this value, u31, so this value, so already got this value, so you have to plug that. Okay, so here we are plugging that, so u21 new value will be 0.00390625, and u31, so we have that boundary value, and we got also u21. Okay, so we have to plug that, we plug that, so new u31 will be this. Now like this way, if I do the Gauss-Seidel method, so here, so node 0 1 2 3 4, so this is 0 1 2 3 and 4, so this node means x is equal to 0 0.25 0.5 0.75, initial t is equal to 0. So initially if I do the first calculation, you will get this, and then after iteration we'll get this value. So here we are doing several iteration, means after 6 iteration if after doing 6 iteration we'll get this final equation, means 2 consecutive value will be same, nearly same, or maybe difference is very small, so we'll get 0.0625 0.01660, this value will get. Okay, so remember this Gauss-Seidel method. Using Gauss-Seidel method we will get that final, after 6 iteration we will get this final value, means this point and this point we will get this value. because in that boundary value is this 0.0625. Using this we will do that second time step. Means we will calculate what will be the value of that nodes at t is equal to 0.0625. so here 1 is 0, 1 is already 0.0098 0098, and 2 00391, u31 we got, so this value, and u14. Now again we have to already t is equal to 0.125, so boundary node, so here this is 0 and this is, you can see here. So now we already got this value, we already got this value, this value, this value. Now we are going to, so boundary value, this value is 0 and this value is 0.125. now using again, so if I want to calculate this value, I need this point, this point, this point, this point, this point, and this point, but this means these 3 points we don't know. Okay, so we have to use Gauss-Seidel method. Okay, so here again, if I want to calculate this, we need this value, this value, this value, this value. So we get one equation. Again, if I want to calculate this, we need this value, this value, this value, this value. Again, if I calculate this, we need this value, this value, this value, and this value. Okay, now 3 equation we'll get. So this is the one equation, this is the another equation. Okay, and another equation is this equation. Now we have to use the Gauss-Seidel method. So for that, so already the initial guess, so here and that intermediate point. Okay, so already we have all this value, so initial guess value means we will take this value from that earlier iteration, means earlier time step already we have. Now we can do that. So first we put that 1/4, u22, that value is 0.0904. okay, and 0.125, that is 42. okay, and 041, so this is, so u21 is this and u41 is this, so we'll get this value. Similarly after several iteration and t is equal to 1 to 5, so we'll get that u02 is 0, u12 this, g22 that is 0.01293, 32 0.05107, and u42 this value. Okay, so here we have to calculate u1 like that, so you will calculate after several iteration, we will get this. Now if I draw that, means here final solution, so here this is x is equal to 0, 0.25, okay, t is equal to 0. okay, so that final solution at t is equal to 0.0625, we'll get that. At t is equal to 0.125, we'll get this value. Okay, now if I plot, we'll get this. So if you see that after time progress, the solution evolves from the initial 0 condition toward a curve profile influenced by the time dependent right boundary condition. Means that these values actually influenced by these boundary values. Okay, because these boundary all are 0, but this boundary we have the value. So now if I do that, means even if I go further time step, it will be like that, it will be like that, it will be like that. Okay, so that is the way to solve that heat equation by using Crank-Nicolson method. So that's it. Thank you.